Hello everyone, welcome to my channel. So we are in reaction mechanism. So in this lecture, I have given some examples to you, which is in belongs to the reaction mechanism. So in this reactions, if they are going to give an acids, what we are going to do? If they are going to give any bases, then what we are going to do? Acid ఇచ్చినప్పుడు reactions అనేది ఎలా చేస్తాము, as well as base ఇచ్చినప్పుడు reaction as well as ఎలా చేస్తాము అనేది today we are going to learn these topics. So I have given some exercises to you. If we are going to solve this all the problems so that we can get what is that exactly reaction mechanism. See here, I am going to explain these questions to you. So first question, you can see the first question. If they are going to give any acids or base to us, what how we are going to do that exercise. So here you can see this first question. In that first question, TSCl and pyridine. Pyridine is nothing but pyridine is a base. Base is nothing but it will take the protons, right? So what will go to the pyridine? Pyridine in the sense it is going to take the proton from here. You can get O minus H. So it is a base, right? Base, it is taking the proton from this OH. So you will get, and after that TSCl, right? In this electronegativity atom, this oxygen is attack on this tosyl group. This chlorine will going to leave. So you will get the compound is OTS. OTS, I think all of you know that it's very best living group, right? So it is going to treated with one second compound. We have a one second compound, right? CH3, C double bond O minus, you can write K plus. So this O minus, it is going to attack on this center. This bond will leave. It is the best living group, right? So how it is going to attack? How it is going to attack? It is in above the plane, right? So if it is above the plane, it is going to attack on the below the plane, like SN2 reaction. Inverted compound will form. So you will get the compound is. So you will get below the plane O C double bond O CH3. After that, you will get this compound. Again, it is treated with a base KOH. This OH minus, it is going to attack on this carbonyl center. This bond is migrated here. This bond is, not this bond. So here you can take this. It is OH is attack on this center, and this bond is migrated here. You will get, so here hydrogen will go above the side, right? If it is in above the side, so you can see here it is a above the side H, below the side O minus. After that work up, so you will get OH. This is for what our product. And if you see the second example, it's very simple. If what is that base, what if they are going to give the base, what we are going to do? If they are going to give the acids, then what we are going to do? We can see here. If you see second one, in the second one, it is a OH. It is treated with H3PO4 phosphoric acid as well as potassium iodide. If you see, it is a acid, right? Acid, what will give the acids? Acid will give the protons to where it is required. If you see this oxygen containing lone pair of electrons, it is going to take the oxygen from hydrogen from here. Then you will get OH H positive, right? You can write like this. So after that, this water molecule is going to remove. So you will get here positive charge. So that positive charge, it is going to treated with Ki. K plus I minus. This I minus is going to attack on this plus. So finally you will get the product is I, right? I. So this is for what your product, right? If you see the third example, so here acid it is given, right? So again one more reaction. If you see, you will take this example, third one. Here sh, it is treated with oh in the presence of HClO4 as well as, so it is a acid, right? Acid, what is going to do the acid? Obviously it will take the hydrogens from here, then you will get OH H positive, right? So if you see, very simple. Yeah, so it is treated with, here we have a one thionyl group, sulfur group, right? So sulfur is attacked and this place water molecule will remove. So finally you will get the compound is yes. So it is, this is for what, your product, right? And next, if you see the one more examples to you, this is a third one. I will give some more example so that you will understand, right? And next one, fourth one, pH. pH, here you have a OH, it is treated with H3PO4 acid. So acid, this lone pair of electrons is going to take the acid from here, then you can get pH. Here OH, H positive charge. So again this water molecule is going to remove, so you will get pH. pH, here you have a positive charge, right? So in that positive charge again it is going to treated with one more pH. So this oxygen, it is going to attack on this place. If you see, what you will get, O, pH, pH, here H. Due to the stability, hydrogen going to remove, so you will get one dimeric form. This is for what, your product, my dear friends. And if you see one more examples to you, ROH, so it is going to treated with NaHMeI. And if you see one more example, sixth one, it is one tertiary group. Here you have a OTS, HSPH, NaOH, as well as heating. So you can take, so here it is a below the plane OTS, as well as same HSPH, NaOH, heating. So you can see these questions, so that we are going to conclude this lecture. See here, it is a base. Base will take the proton from here, right? You will get negative charge. Negative charge is attack on this methyl group. This iodine will leave. Obviously, you can write directly OMe. This is for what, your product. I hope you understand this reaction, right? So if we see this cyclohexane reaction, cyclohexane, uh, it when they people are going to give this type of questions to you, you can write it in a chair form. You can write like this, right? So it is in above the plane, right? So this is also in above the plane, so you above the plane you should write OTS. So if you see this base, what is going to do the base is take the proton from in this H, so you will get HSP, I mean SPH minus PHS. You can write PHS, you can write PHS. So it is a axial, right? axial. So where it is going to attack on this chair, it is going to attack on equatorial. If it is in equatorial, it is going to attack an axial. So right now it is in axial, right? So it is attack on equatorial. It is in above the plane, it is going to work SPH. I hope you can write this one in a cyclohexane manner. It is above the plane, right? So this is for what? It is in below the plane. It is comes under SPH, right? That is for what? This reaction. I same, yeah, the same you can see here. It is also, you can write, it is in above the plane. So here it is in a below the plane, right? So here you can write OTS. So SPH minus, it is going to attack an axial because it is in equatorial, right? So it is going to attack an axial. Axial in the sense, you will write here SPH. So if you write in a normal manner, so you can write it is above the plane. So it is also in above the plane. SPH. This is for what? Our total exercise of this lecture. So very simple in this reaction mechanism. If they are going to give the acids, so how we are able to perform the reaction. If they are going to the bases, how we are going to perform the reactions. Very simple. So if they are going to give the acids, then you can donate the protons to where it is required. And if you they are giving the bases to us, so we will remove the protons from where it is where it is available and that compound. So that's it today lecture. I hope you understand this lecture, right? So thanks for watching this video to everyone. Thank you.